All right, so now we've been dealing with systems of linear equations. We're going to work with how these relate in word problems, story problems, and how to set them up. So really the biggest thing is just deciphering how to set them up. Once you set them up, then you use the skills that we've learned to solve for them. So I just put some kind of notes or reminders on here. So when we're dealing with systems, one thing we're going to be looking for with these story problems is we're going to identify two totals. Usually one total has to deal with money and the other has to deal with total amount of items. So think about that as we're reading these next couple problems as examples. Then we're going to identify what the variables are. You're usually dealing with two different items or objects. Then we're going to set up our two equations, and then we'll have to just note what variables go with each total. For these, one's going to have coefficients, one's not going to have coefficients, and you'll see what I mean as we go through those, and then you solve the system. All right, so our first example is, suppose your class sells gift wrap for $4 per package and greeting cards for $10 per package. Your class sells 250 packages in all and receives a total of $1,084. Find the number of packages of gift wrap and the number of packages of greeting cards sold. You might want to read these a couple times just so you understand them a little bit, because they can be kind of wordy. But the first thing we're going to identify are what are our two totals identified in the problem. So again, kind of like what I said earlier, one is usually going to be a money total and one is going to be the total amount of items. So in this case, we have 205 packages sold for a total of $1,084. So our two totals are 205 and 1,084. Now from a variable standpoint, we need to identify what the variables are. So we have packages, and what we're selling are two different gift wrap packages. So one's greeting cards and one is gift wrap. So the gift wrap's $4 per package and the greeting cards are $10 per package, but our two variables, the two differences, are greeting cards and gift wrap. So I can call like gift wrap X and greeting cards Y, but those would be our two variables. So gift wrapped, let's call that X, and cards Y. We're going to just put the variables by them. You can call it W and C for gift wrap and cards. It doesn't matter, but we're used to using X and Y, so I'm going to stick with that. The coefficients that go with each variable, now we have our gift wrap, we know that it's 4, so that would be 4 for our gift wrap, and our greeting cards would be 10 because they're per. So as we're setting this up, this would be our 4x, our 10y, etc. So then we're going to set up the equation. So when we are setting up equation, one is going to be with coefficient, one's going to be without. So our total packages are 205. So our gift wrap and our cards together equals 205. So I can say X plus Y equals 205 packages. So that's just our total packages. Doesn't have anything to do with how much things cost. So now our second one, we're going to set up the one that we have the variables with. In this case, $4 per package, $10 per package, total $1,084. So that would be 4x plus 10y equals 1,084. Once you have this set up, now we can solve by elimination, substitution if you want to isolate one of the variables, but this is set up for substitution with manipulating one of the problems. So you can pause this, you can solve it from here, you should be okay with that, but that's the general setup and how we do it. So I'm just going to go ahead and run through this problem. So I'm going to multiply this. I'm going to eliminate the x's, so I'm going to multiply everything by -4. So that's going to give us -4x minus 4y equals -4 times 205 is -820. So I'm going to use these two and combine them. These cancel out. That's good. So I have 6y equals whatever 1,084 minus 820 is, which would be 264. And of course we divide by 6 now. That'll give us our y. And that equals y equals 44. There's half of our answer. I'm going to use my original, this x plus y equals 205, just because it's lower numbers. I'm going to put y for 44. So when I set up the second problem, I have x plus 44 equals 205. Subtract 44 from both sides. And x equals 161. So our two amount of packages, this totals 205. And if we put these in for x and y here, that will total out to 1084. So go ahead and take a look at the second one. Maybe pause this, see if you can set it up. Then unpause it and we'll walk through it. So reading this, tickets at a local movie were sold at $4 for adults, $2.50 for students. There were 450 tickets sold for a total of $1,575. Solve by elimination to find the number of adult tickets sold and the number of student tickets sold. So we're looking for our two totals. In this case, it's just the total amount of tickets and the total amount of money sold. So we have 450 tickets, 1,575 is our money total. So now we have to set up our variables. Our variables on this are adult tickets and student tickets. So again, you can call this A and S. You can call it X and Y, whatever is easiest for you. I'm going to use X and Y, again, because it's something you're familiar with. So if my total adult tickets and total student tickets total 450, I could represent that as X plus Y. So just our total amount of tickets equals that. Now we work into the price aspect of it, like how much were each ticket. So adult tickets cost $4 a piece and students cost $2.50. So I can call that 4X plus 2.5Y. I can put the 0 here if I want, but it's not necessary. All right, so now we're at our regular setup here. So if you want to go ahead and pause this and do it and then check your answer, you can go ahead and do that. I'm going to eliminate the x's first. So I am going to multiply this. Conveniently, it's just similar to this. I'm going to multiply this by -4. You can multiply it by -2.5 to get the y's to cancel out. But either way, so I'm going to distribute this -4 throughout the problem. -4x minus 4y equals -4 times 450, which gives us -1800. Now I'm going to combine these two systems. These cancel out. 2.5 minus 4 gives us -1.5 y. And then I have 1,575 minus 1,800. That gives me -225. And then to solve for y, we're going to divide by -1.5. So -225 divided by -1.5 is going to give us 150. So y equals 150, and y we know is our student tickets. So now we have to figure out how many adult tickets were sold. I'm going to use this first equation again. A lot of these, the second setup is pretty straightforward. So I'm going to use x plus y equals 450, and in this case y equals 150. So x plus 150 equals 450. Subtract 150 from both sides. And x equals 300. All right, so that's the setup. The big part is like deciphering what your two totals are and everything. And again, these are set up. These are examples of story problems where you can set up a system of linear equations and then solve for them.